Alright, so in this video, I'm going to be solving the equation x minus 4 to the power of 4 is equal to x to the power of 4. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. What I'm first going to do is rewrite this equation as x minus 4 to the power of 2 times 2 is equal to x to the power of 2 times 2. And the reason I did this is because now I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So using this property, I can rewrite x minus 4 to the power of 2 times 2 as x minus 4 to the power of 2 to the power of 2, and I can rewrite x to the power of 2 times 2 as x to the power of 2 to the power of 2. Now from here, this is going to turn into x minus 4 to the power of 2 to the power of 2 minus x to the power of 2 to the power of 2 is equal to 0, because I just subtracted x to the power of 2 to the power of 2 on both sides. And now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is x minus 4 squared and b is x squared. So this turns into x minus 4 squared plus x squared times x minus 4 squared minus x squared is equal to 0. Now from here, I'm going to expand x minus 4 squared. So x minus 4 squared is equal to x squared minus 8x plus 16. So over here, I get x squared minus 8x plus 16 plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. Now x squared plus x squared is 2x squared. So I get 2x squared minus 8x plus 16 times, these two cancel out, negative 8x plus 16 is equal to 0. And now I get two equations. 2x squared minus 8x plus 16 is equal to 0, and negative 8x plus 16 is equal to 0. Now from here, I'm going to factor out 2, so I get 2 times x squared minus 4x plus 8 is equal to 0. And from here, for this equation, I have 8x is equal to 16. So if I divide both sides by 2, I get x equals 2. That's one solution. And now continuing this, if I divide both sides by 2, I get x squared minus 4x plus 8 is equal to 0. And if I use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 1, b is negative 4, and c is 8. So I have x is equal to negative of negative 4 plus or minus the square root of b squared, so negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2 times 1. And this turns into 4 plus or minus the square root of 16 minus 32 over 2, which turns into 4 plus or minus the square root of negative 16 over 2. So now, the square root of negative 16, I can rewrite that as the square root of 16 times the square root of negative 1 over 2, and the square root of negative 1 is equal to I. So I get x is equal to 4 plus or minus the square root of 16i over 2, and the square root of 16 is equal to 4, so I get x is equal to 4 plus or minus 4i over 2, which turns into 2 plus or minus 2i. So my three solutions of x are x is equal to 2 plus 2i, x is equal to 2 minus 2i, and x is equal to 2.
Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.